Hi, today I would like to give you some resources to help you with the probability and genetics assignment. So we are combining math and science significantly. And so we are going to use science words and we're going to practice some probability with it. So the first thing is up here. It says pretend that the following genotypes are on separate cards. So genotypes, if you think back to science, those are the two letters together. And so you would want to count how many different cards there are right here. And so there would be 16. And then down here it says, what's the probability of getting a homozygous genotype? So homozygous, it's going to have both capital letters or both lowercase letters to count. So to remember, probability is how many give you what you want out of how many total. So this one have two uppercase A's. These are heterozygous. This one has two lowercase K's, two uppercase L's, two uppercase D's. Those are heterozygous. These are homozygous because they're the same. So are those, these, and these have all the, they're all homozygous. So when you count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So remember, probability says how many give you what you want, 9 out of how many total, 16. And then for this part, how do we know that? Because homozygous means that they have both capital, both lowercase, say something like that. Maybe you just say that there are 9 that are homozygous, whatever you would like to say. Now I would like to come down here and work through this example problem with you, and then you will do the 2 on the back on your own. So looking down here, it says in Tigers, stripes are dominant to polka dots. Cross a heterozygous boy striped tiger with a homozygous polka dot girl tiger. Oh, striped tiger, sorry. So the boy is heterozygous, which means that he's going to have a capital letter and a lowercase letter. We do not want to use S, which would probably be like the first thing I would think of, but we don't want to use S because it's hard to see which is capital and which is lowercase. So I'm just going to use T. And so the boy is heterozygous. So you'll have an uppercase T and a lowercase t. And then the girl is homozygous polka dot. Polka dot, if you go here, so stripes are dominant, that means polka dot is recessive. So she would have 2 little t's. So then when you go to match these, this option would have a big T and a little t. Here we'd have a big T and a little t. Here we'd have a little t and a little t. And here we'd have a little t and a little t. So here's what your Punnett square should look like. So then here, your boy parent genotype. So again, the boy was heterozygous, so he's gonna have an uppercase and a lowercase. The girl was a homozygous recessive, so she's gonna have 2 lowercase. So then when you, to get to this part, you will need, for the possible offspring genotypes, you need to look inside your Punnett square. So there could be a big T, little t, or little t, little t. So you'll see that there are 2 that look like that and 2 that look like that. So then we want to look at probabilities. So the probability of having a heterozygous, if you think of it, what heterozygous probability, how many give you what you want out of how many total. So if you look here, there are 2 out of 4, which equals 1/2. And then for the little t, 2 give you what you want. There's 2 little t's out of 4 total. So again, 2 out of 4, which equals 1/2. So then the possible offspring phenotype. So I always remember pheno is how they physically look, And so that's how I remember what the difference between geno and pheno. And so physically, if you're a big T, little t, you have stripes. If you are a little t, you are a polka dot. And then for the probabilities, if you're a big T, little t, your stripes, so that's 1/2. And then polka dots, those are going to be the ones that are the little t, so also 1/2. And that's how you do that example problem. So then you, on page 2, you'll be able to look back at this, and I want you to try to work out problems 2 and 3. And then down here, you're going to see where we talk about dependent event. I want to work through the first example with you. So you have a packet of seeds to plant in your garden where round seeds are dominant to wrinkled seeds. Once you plant a seed, it is removed from the packet. Okay, so like you plant a seed, now the seed's no longer there, you have one less in your packet. So you have 10 heterozygous, 3 homozygous dominant, and 2 homozygous recessive. So what would be the probability of planting a big R, and then planting a little r? So to show your work on here, a big R, think about how many give you what you want. 3 out of how many total? 10 plus 3 plus 2 is 15. And then you have, put a space in there so you can see it. For the little r, there are 2 give you what you want. And remember, you've planted a big R. It's gone. Like you always assume you got what you want. So the big R is gone. And so now instead of having 15 seeds, you only have 14. And then you can either, when you go to multiply these, you can multiply straight across the numerators and the denominators and then simplify. I like to simplify before just because it makes my math easier. And so it's just really hard to do when it's like this and not right up inside each other. But I know 3 out of 15, I could change that to a 1 out of 5 because I could divide both by 3. And then I could change 2 and 14 to simplify, and it would be 1 out of 7. And so then I can multiply straight across. 1 times 1 is 1. And then 5 times 7 is 35. And then your answer would be 1 out of 35. Please go through and type your answer over here too. And that's how you do that problem. So you're going to go through and you're going to, how many give you what you want out of how many total? And then do it again. How many give you what you want out of how many total? Hopefully that will help you. And if you need more help or want me to go through another example with you individually, please let me know. Thanks.